For question 18, in the graph shown below, curve X represents the results of the reaction between 10 grams of zinc granules and 100 cm cube of 1 mole per dm cube dilute hydrochloric acid at 25 degrees Celsius. So which of the following changes would produce curve Y? Now, our first step would be to identify the limiting reagent. However, because this question didn't state who is added in excess, who is the limiting reagent, so we will need to do some more calculations to help us identify the limiting reagent. So I will write the chemical equation between hydrochloric acid and zinc. This is an acid metal reaction, so it will give you a salt, zinc chloride, as well as hydrogen gas. Okay, and I'm going to balance the equation. Now, I have 10 grams of zinc and I have 100 cm cube, 1 mole per dm cube of hydrochloric acid. So my first step would be to calculate the number of moles of both reagents. So, number of moles of hydrochloric acid, okay, is equals to volume times concentration. So 100 over 1000 dm cube times 1 mole per dm cube. So that would be 0.1 mole. Okay, and for the number of moles of zinc is equals to mass over AR. So 10 grams divided by 65. That is 0.15384 moles. Okay, so my next step would be to compare mole ratio of both reagents. So of hydrochloric acid and zinc. So from the equation, okay, I'm comparing the coefficient here. So it is a 2:1 ratio. So if I have 0.1 moles of hydrochloric acid, based on the mole ratio 2:1, it means that I require 0.05 moles of zinc. Okay, however, I have 0.15384 moles available. So I only need 0.05, but I have 0.15384 moles available. So this means that zinc is in excess. So hydrochloric is the limiting reagent. Okay, so hydrochloric acid is limiting reagent. Now let's focus on the two aspects of your speed of reaction graph. The first aspect is the maximum volume of gas evolved. Okay, which depends on the number of moles of limiting reagent. So what do I mean by this? In curve X, okay, if I have 0.1 moles of limiting reagent, which is your hydrochloric acid, and it produces this volume of gas, in curve Y, if I have half the maximum volume of gas, this means that I would also have half the number of moles of limiting reagent. Means in curve Y, I'm expecting 0.05 moles of your hydrochloric acid. Okay, so now let's look at the four options to see which one corresponds and produce 0.05 moles of hydrochloric acid. So I'll focus on options B, C, and D first. Okay, we have the volume as well as the concentration of your acid. So we can calculate the number of moles. So for option B, okay, 25 over 1000 dm cube times 2, that would give you 0.05 moles of HCl. Okay, and for option C, you have 50 over 1000 times 0.5. So that will give you 0.0250 moles of hydrochloric acid. So straight away, I will eliminate C. Okay, because the number of moles of acid does not tally with 0.05 moles. And for option D, 100 over 1000 times 2, that will give you 0.2 moles. Again, I will cross out D because it doesn't tally with 0.05 moles. Okay, so the correct answer is B. because it gives me 0.05 moles of hydrochloric acid. And also, if you look at the gradient factor, okay, I have a higher concentration of acid compared to 1 mole per dm cube. And I also have a higher temperature compared to 25 degrees Celsius in curve X. So higher concentration or higher temperature, it will result in a faster speed of reaction, which is represented by a steeper gradient. And if you look at the curve, okay, for curve Y, it has a steeper gradient. So all the factors, they do tally with the graph as well as the number of moles of your limiting reagent. So answer will be option B. Okay, A cannot be the answer because when I use half the mass of your zinc, which is in excess, okay, it has no effect on the number of moles of your limiting reagent. So it will not change the total volume of gas produced if I use half the mass of zinc. Okay, so answer for question 18, it will be option B.